Manufacturers use robots in place of direct labor to increase production efficiency while reducing cost. This helps companies increase their cost competitiveness and frees up employees to focus on jobs that require their skill. Overall, robotic automation gives companies the ability to do more with less. As the popularity of robotics has increased, the cost of robotic systems has decreased. This has allowed more companies to take advantage of automation through the use of robotics. The end-of-arm tool, which is also called an end effector, is critical for a robot to complete a specific task. It is a key component for the productivity and accuracy of a robot's operation. It allows the robot to perform operations associated with palletizing, product handling, sorting, machine tending, mechanical or pneumatic gripping, and metrology. With the assistance of FDM technology for 3D printing, making a custom end-of-arm tool is now quicker and easier than ever before. The process starts by designing an end-of-arm tool in a CAD program. When using FDM technology, designers have greater freedom to create an end-of-arm tool that is not limited by traditional machining methods. For example, FDM can incorporate internal passages to serve as vacuum channels. These enable the robotic tooling to vacuum grip parts without external vacuum hoses that can be damaged or snagged. What's more, FDM end-of-arm tools can be 3D printed to include complex or organic geometry while keeping manufacturing costs low. Exported as an STL file, the design becomes the digital definition of the end-of-arm tool. Each STL file is then prepared in Insight, a software application that creates the operating instructions for the 3D printer. The performance of the end-of-arm tools can be further optimized by leveraging FDM's internal fill controls. The strength and therefore the durability can be improved by increasing the density of a feature to make it better suited for operations such as mounting or threading. On the other hand, decreasing the density of internal structures creates lightweight tools that enable more of the robot's payload to be utilized for heavier work pieces. Region by region, the fill density can be adjusted to custom tailor the tool's performance by creating gradient densities throughout. Next, the file is uploaded to the FDM 3D printer, where the automated toolmaking process begins with the click of a button. Once the print job is complete, the part is removed from the build chamber and any sacrificial support material is dissolved or detached. Now the FDM parts can be fitted with all the supporting components required to make a functional tool. These may include fittings, tool changers, gaskets, sensors, paint guns, welders, mechanical or pneumatic fingers, and other components. The end-of-arm tool is now ready to be mounted to the robot so that it can do the task it was designed for. FDM is a best fit for end-of-arm tools that are designed and manufactured specifically for the robot's task. In other words, when off-the-shelf end-of-arm tools just won't do. Use FDM when testing and validating a new robot program that uses a new end-of-arm tool design. Or use it for low-volume fabrication of up to 100 end-of-arm tools. To get the most out of FDM, use it for the components of an end-of-arm tool with designs that are challenging to machine. But even simple shapes are ideal candidates if lightweight tools can improve production line operations, or if you want to bring end-of-arm tool manufacturing in-house. Look for end-of-arm tools with these conditions and those where durable, stable thermoplastic will perform as needed. FDM reduces the time required to put a robot to work, removing the bottleneck, making custom end-of-arm tools. Companies that use FDM end-of-arm tools realize savings of 70 to 85% in the time to make them when compared to CNC machining, and cut the cost by 75 to 85%. Those reductions are true even when making optimized end-of-arm tools that leverage the design freedoms that FDM creates. Add internal vacuum channels to eliminate hoses, combine multi-piece assemblies into a single part, and integrate hardware like magnets, sensors, or RFID tags. Complex designs don't add time or cost. Optimized for the task, your robot will do the job better and faster. Made from thermoplastics, the end-of-arm tool will also be lighter, which means the robot can travel faster, carry more payload, and operate longer between preventive maintenance cycles. Thermoplastic also means that your end-of-arm tool won't scratch the part it manipulates, and should the robot strike something in its path, the thermoplastic will dampen the impact force, which may prevent a costly repair. FDM lets you bring end-of-arm tool making in-house, giving you the ability to respond quickly to design changes and replacements. And with FDM's speed, production lines don't need to wait for new and redesigned end-of-arm tools. Robotic automation increases production efficiency while reducing cost. Take a look at FDM to see how much more efficiency and savings you can add to your production lines. To learn how much you can benefit, contact Stratasys Application Support.